Welcome to today's episode of our podcast, where we dive into the fascinating world of asynchronous programming, specifically how to visualize that asynchronous magic in Rust. I know it sounds a bit nerdy, right? But trust me, it's going to be a fun ride, especially if you're a visual or experimental learner like many of us out there. So let's kick things off with a friendly question. Have you ever found yourself tangled in the web of async code, wondering what's actually happening under the hood? Well, today we're going to unpack that by actually visualizing async execution using some cool tools. You see, async programming is like hosting a dinner party. You've got multiple guests or tasks who want to be served or executed, but they can't all be at the dinner table at once, right? They need to take turns, which is kinda how async execution works. But what if you could see this dinner party unfolding in real time? That's exactly what we're digging into today with sine wave calculations. We start by creating future tasks to compute values of the sine function asynchronously. Imagine us plotting these values over time, kind of like drawing a picture of how all these tasks are interacting. And oh boy, when we plot these graphs, it's like looking at a dance floor where two sine waves are swinging side by side. Let's break down a crucial part. We're using Tokio, a powerful async runtime in Rust. Our little sine wave program takes an asynchronous approach to calculate these values. We launch multiple futures, each capable of competing for execution time without stepping on each other's toes. This visualization allows us to see whether our tasks are executing concurrently or if they're truly running in parallel. And here's an interesting twist. When we layered in a more CPU-intensive function for calculating sine values, things got a bit chaotic. Imagine one party guest hogging the punch bowl while everyone else is waiting for a turn. We saw our high CPU task slowing down our other fast sine calculations because they all had to compete for the same CPU resources. This is a wake-up moment for anyone dabbling in async programming. CPU-bound tasks can cripple the efficiency of async code. But don't worry. Rust Tokio has some tricks up its sleeve. We can spawn new tasks within the multi-threaded runtime, allowing better use of our CPU's cores. It's like opening up another buffet table for more diverse food choices. Each of our async tasks can now be distributed across multiple threads, effectively dividing the workload. The result? Smoother execution and timely sine calculations. And here's where it gets even more fun. We introduced spawn blocking, a method that lets us deal with CPU-heavy operations without getting in the way of other tasks. Imagine it as a dedicated line for dessert so the main course can continue being served smoothly. This discovery was quite profound. We could see how task behavior changes with blocking versus non-blocking techniques, all while keeping an eye on performance through our visual aids. To wrap up, visualizing async programming gives us much-needed clarity. We can intuitively understand the difference between concurrent and parallel tasks and optimize them based on what we see. Async programming in Rust might seem complex, but as we've explored today, with the right visual tools, it's much easier to grasp. So what's the takeaway from today's episode? If you're diving into async programming, don't shy away from visualizing. It can help you demystify what's going on behind the scenes and optimize your code. Thanks for tuning in. And before you go, I'd love to hear your thoughts. How do you visualize your own coding challenges? Do you have any favorite tools or techniques? Until next time, keep tinkering and exploring the wonderful world of asynchronous programming.